Hello everyone, welcome to Pseudocoder. This is Ravina, and today we are going to look at the most asked question at Facebook or Meta in the last 6 months. So, if you see, if I look for all the Facebook problems and I'm looking for the 6 months, and if I sort them by frequency, we get a problem binary tree vertical order traversal. So, today we are going to have a look at this one. So, let's start by reading the question here. So the question says that given the root of the binary tree, return the vertical order traversal of its nodes values, that is from top to bottom, column by column. If two nodes are in the same row and column, the order should be from left to right. We have an example, but you know me, we are going to have a look at this in my notepad. So let's move on to my notepad. Here I have taken the first example that is given on Leetcode. So let's see what the problem statement is. So what we have to do is we are given a binary tree and we have to get its vertical order. So for example, now this is a binary tree. I'm going to divide it in vertical sections, column by column. So these dotted lines define that these are the columns. And then if you see, this can be column 1, 2, 3, and 4. So what the problem statement is saying that we have to do a vertical order traversal. So starting from this, going down, vertical order traversal from top to bottom. If we do that, what is going to be our result? Result is going to be 1 going from top to bottom. So we get 9 first. So 9, and 9 is the only element in this particular column, so that is going to be its own list. Then we go to the next column, we see there is 3, so 3 comes here, and then as we go down we get 15. There is nothing beyond 15, so that is going to be the second list. Going on to the third column, we get 20, so we add 20, and then there is nothing below it, so that is all. And then in the fourth column you can see there is just one node, 7, so you have 7. So this is going to be the answer, a list of list where each sublist is going to be a column where we have nodes from top to bottom. We also have another condition that the problem statement says that if a particular element is in the same row and column, then you have to traverse it from left to right. For example, suppose 9 had, this is just my simple example, that 8 or 12. In this case, if you see 12 and 15 is in the same row and they are also in the same column. So in this case, when we try to traverse it, it is going to be 3 since it's coming from top to bottom, and then these two are at the same place, so we go from left to right. So 3, 12, and then 15. So this is the problem statement. Let's see how we can solve this problem. I have taken this example again right here. Today we are going to solve this using breadth first search. If you know me, I use the same typical code that I have for breadth first search and depth first search. I just make some simple modifications in that code, and that makes it really, really easy to understand these problems and to have kind of a base, you know, uh, a base outline to stick to. If you don't know what I'm talking about, please go in the description below and click on the BFS DFS video that I have, and you will have the base code for it as well. So moving on, we are going to solve this using breadth first search. We are going to use a small trick here. We are going to use a dictionary. Since we have to make sure that all we have to basically return a result where it is going to have a list of all the nodes in a particular column. So that makes me think, how can I do it? So if I maintain a dictionary where they say column as a key and then value adds a list of nodes, it could work, right? If I have say 2 as my key and then I store 3, 12, 15 as my list of values, that could work. That is something that we want. So for this particular example, the first thing that we need is the dictionary. So I'm going to make a dictionary. I'm going to make it here. Okay. So this is going to be my dictionary. Second thing we need, since it's a BFS problem, we are going to need a queue. So we have a queue, which I'm going to write here. Now, what are we going to initialize the queue with? Queue is going to be initialized with a tuple, where a tuple is going to be a root and its column values. So we are going to do is, what we are going to do is, we are going to give our first element, the root element, a column value. So for example, I give it as column 0. Whenever I traverse to the left or to the right, I make changes to my column. For example, when I move to the left, I'm going to subtract -1 from my column. So 0 minus 1, which is -1. Whenever I go to the right, I'm going to add +1 to my column. So my column is 0 and then +1. So that is going to be 1. Again, when I go to the left, it's going to take the column that is here, so 1. And then since I'm going to the left, I'm going to subtract 1. So it is going to get 0. And if you move to the right, you're going to take that same column value, so 1, and then add 1 to it. So it becomes 2. So you see the pattern here. Did you see what I did? This is 0. Since we subtracted 1 from here, this ended up to be the 0. So that means that 3 and 15 are in the same column. 9 has a column of -1, 20 as column 1, and then 7 is in the column number 2. So that is one trick that we are going to use to solve this one. Okay, so I'm going to rub everything off and then walk you through it step by step. Okay, uh, we are going to initialize the queue with a tuple, as I said before, and the tuple is going to be the root itself. So in this case, 3, and then I'm going to add a column to it. So I said we initialize column with 0, so I add 0. So that's the tuple I have. Now, in the BFS problems, we go through the queue, we pop things, and then we see if there is anything on the left and right, and then we keep adding to the queue and popping things out of the queue. The logic that we are going to add in this BFS algorithm is to add things to our dictionary, and that is going to help us to get the result. Now, I go through the queue, I pop things. So I pop it. I have my current node as 3 and then my column as 0 since I popped it out of the queue. Once I do that, I'm going to add this thing to my dictionary. So I'm going to add column 0. So first I will check, does my dictionary have a key of 0? It does not. So I create a new key as 0, and then in the value I add the current node's value. So I add 3. The next step here is to check, is there anything on the left of our current node? So I check on the left. Yes, there is 9. Okay, so what I do is I create another tuple. I add 9 as the node to it. Now we also have to store the column. What is going to be the column? The column is whatever the column value right now, so 0, and then we subtract 1 from it. Why subtract? Because we are going to the left. Whenever we go to the left, we subtract 1. When we go to the right, we add 1. So we subtract, so we subtract 1 from it. It becomes -1. I add that to my tuple. I check, is there anything on the right hand side of the current node? Yes, there is. We have 20. So we add that to the tuple, and in terms of the column, it is since we are going to the right, whatever the column value right now, which is 0, and then add 1 to it. So 0 plus 1 is going to be 1. So that becomes the value. Since we have explored both the left and right parts of the current node, then we go in again into the queue and then explore all the elements. So the next up is 9 and -1. So we pop that from the queue. So our current node becomes 9 and the current column becomes -1. The next step here is to look for the key -1 in the dictionary. Do we have it? No, we do not. So we create one. We create a key with -1, and then the value for it is going to be the list. and the current node's value. Now we check. Is there anything on the left hand side of node 9? No, there is nothing. Okay. We check, is there anything on the right hand side of the node 9, which is the current node? There is nothing. Okay. Our job here is done. We go into the queue again and then we pop the next element present. So we pop 20. So our current element becomes 20 and then the column becomes 1. We check in our dictionary. Do we have a key with one value? No, we do not. So we create that entry and then in terms of the value, we add the current node's value, which is 20 right now. Next thing, we just explore the elements to the left and right. So is there anything on the left hand side of 20? Yes, there is. We have 15. Okay, so we create a tuple with 15 node. In terms of the column, whatever the column value is right now, so 1. So 1. And then since we are going to the left, we subtract 1. So 1 minus 1 is 0. We add 0. Now we explore the elements on the right hand side of the current node. So here we have 7. So we create a tuple, we add 7 to it. And then what is going to be the column? Whatever the current value is for column 1. So this one. And then since we are going to the right, we add 1. So 1 plus 1 is 2. So the column becomes 2. If you have a look at what we just did here, you see that we got 0 here. And then after adding 1 to it, and then after subtracting 1 to it, you see that we again got 0. That means these are in the same column. So that's something that, I found that was really interesting to notice. Okay, moving on. We explored left and right elements. So we are going to do what? We are going to now pop things from our queue. The next up for us is 15 and 0. So we pop 15 and 0. We update this. So current node becomes 15 and the column becomes 0. We go back to our dictionary. Is there a key with value 0? Yes, we do have it. It's right here. Okay, so we don't have to create a new entry now. We can just add it to this list. So we add the current node's value to the list. We check, is there anything on the left or right of 15? There is nothing. All right, we are good. We go back to the queue. We pop the next element that we have. So here we have current element is going to be 7 and then the column value is going to be 2. We check in our dictionary. Is there anything with the key 2? No, there is none. Okay, so we create new key and then in the value we add the current node's value. Later we check, is there anything on the left and right of the current element 7? There is nothing. All right, we go back to the queue. There is nothing in the queue. The queue is empty. We come out of our while loop. Now you'll see that in the dictionary we have now all the columns that are there in the tree, the column 0 -1 1 2, and we have all the nodes that are being assigned in one or the other columns. Now what to do next? So now we have to make sure that whenever we have the columns in place, we have to go from left to right. So what do I mean is that once we have the column, so let me use orange here. Once we have the column, we have to make sure that we go from left to right. So in the answer, we knew that 9 comes first, right? 9 comes. This was something that I used later, but yeah. So if you look at this particular example, a 9 comes first. So 9 is going to be the first sublist, and then 3 and 15, and then so on. So we go from right to left and also top to bottom. And since we have these columns which are labeled in numbers, and we did that intentionally so that we could later sort them, is why we did it. Okay, so we are going to sort this dictionary by keys now. So the first element that we get is going to be this -1. That's the smallest one. So we get -1 and then the element in it, which is 9. The second is going to be 0. So we get 0 and then the elements in it. So 3 and 15. Now comes 1. So we have 1 with 20, and then lastly 2. Once we have them sorted, this is literally the answer that we have. So the next thing would be just to add these particular lists as part of a bigger list. So we create a list, and then we add 9. Then we go in and we add 3 and 15. The next thing is add 20, and then 7. If we look at the result, this is what we need. So this is how you solve this vertical order traversal problem. Now let's see how we can code this in Python. First things first, we have to always look at the constraints that we have. So if you see here, it says the number of nodes in the tree is in the range 0 and 100. That means there can be 0 number of nodes in the tree. That means your root can be null. So that is the first check that we need to have. Always, always, always look for the constraints. Even if you are in an interview or anyone asks you to solve a problem, always ask these questions. So our edge case here is going to be if not root. That means if the root is none, then you return an empty list. Now, the first thing that we did was we needed a dictionary. So I'm going to get a dictionary of nodes, and then I want a default dict where my value is a list. So that's how you do it in Python. We need a result, and lastly, we need a queue. I'm going to initialize my queue with which is going to be a tuple of root and the column. Initially I had my column as 0, so I'm going to just write it as 0. Then comes the while loop, the most important part. So while my queue is not empty, what I do is I'm going to pop things from my queue. So I do a queue dot pop, and we are going to pop the first element of the queue. So that is that. And then since we added it as a tuple, the first thing we added was a root, was this root, and then the next was this column. So my first node is going to be current, which is going to be the current node, and then the second is going to be the column. And now I have my current node and my column. So the next thing I'm going to do is I'm going to add it to my dictionary. So you can do dict.nodes, and my key is column, so I add it to the parentheses. And since it's a list, I'm going to append the current node's value. Now, why am I not appending the current node directly, but only the value? The reason is we don't really need to keep track of the current node because we don't want the next or previous or any other nodes related to that. And we don't need that for the result. So that's why we are just storing the values and not the whole node. The next thing, check the left and right. So if current dot left, if there is anything to the left, then you do q dot append. What do you append? You append the current node's left. So current dot left, oops, current dot left. And then since we are going to the left, what do? We subtract 1 from the column. So we subtract 1. Now we check for if current dot right. So if there is anything on the right hand side of current, what we do is we append it to the queue. So q dot append, and then you do a current dot right. And what is going to be your column? Your column is going to be column plus 1. Since we are going to the right hand side, we do column plus 1. Yeah, we do column plus 1. Okay, if we now what to do now? So now we have done everything, adding to the queue, processing everything. Now we have the dictionary. The next thing would be to sort the dictionary, correct? So for k in sorted, So I'm going to sort my dictionary based on the keys. So that is going to be dict nodes dot keys. And once I have them sorted, I'm going to add it to my result. So result dot append, I add whatever comes in my dict nodes value. In the end, I return the result. Let's see if we can run it. Okay. Okay, so test cases are accepted. Why is it argument tuple assigned? Okay, that's fine. And then I'm going to submit it. Okay, so it was submitted. It beats 19.72% of the Python users. Now, let's talk about the space and complexity of this problem. Let's talk about the time complexity first. Time complexity for this problem is going to be, we are going through each and element in the tree. So that is n. But if you look at here, if you look at this, we are sorting the dictionary. And the sorting, as you know, takes n log n time. And for the worst case scenario, if there is just one element per column, it is going to be n elements. And so the time complexity of this problem is going to be n log n. As for the space complexity, how much space do we need to store things? So we have a dictionary that stores all the nodes, and then we have a queue. So here, if you see, at the worst case is going to be queue is going to store all the elements. So that is n. And then the same goes for dict nodes. If you have columns and each element in one column, the worst case scenario would be it will take n space. So n plus n is 2n, and I mean, you know that in space complexity we just drop the constant. So the space complexity of this problem is going to be O of n. I hope this explanation was helpful. The code for this is going to be on my GitHub repo. I will add the link to it in the description below. And please make sure that you check out the breadth for search or depth for search video if you don't know the code or are not familiarized with the code. And let me know if you liked my video, and give it a thumbs up and subscribe to it. It helps me keep motivated to add more videos like this. So thank you so much for watching, and I will see you next time.